Okay. All right. And we're going to have a look now. We've dealt with expanding and factorising of quadratic equations, and we've looked at mainly examples where we end up with two brackets. What we're going to look at now is actually solving equations that involve quadratics. Now, there's a couple of key things to understand about this before we start. The first of them is, I'm just going to jot them up here. If I want the answer to the square root of 25, or let's just say I know that x squared equals 25, what are my answers to this? All right, and you might say, all right, x is equal to the square root of 25, which is correct, and that would give me x equals 5, and we've done Pythagoras recently, and you'll know that, but there's another answer. You can also have x being negative 5, because of course negative 5 times itself also equals 25. So that's the first thing to get out, the fact that often there are two answers for an x squared equation. The second thing to get our heads around is the fact that if we multiply two numbers together and we want the answer to be 0, what can you tell me about letter A or letter B? And here we get to a point what we call as the null factor law. Null because it equals 0, factors because they are multiplied together, and the law. And the law basically states that if there are two factors multiplied together, one of those factors must be equal to 0. So if A was equal to 0, doesn't matter what B is, the answer is going to be 0. Alternatively, if A was equal to some strange number and B was equal to 0, there we are. So the truth is, if you have an equation that looks like this with two things multiplied together, there are two possible answers. A is 0 or B is 0. And that brings us to these quadratic equations. I want to start with the example here. In this case, we have two things, two brackets, which are multiplied together for some reason. But what I know is, because it equals 0, if that bracket there or that bracket there are equal to 0, then my final answer will be 0. And what we do here is we say basically either x plus 2 has to be equal to 0, or the alternative answer over here is that 5 take away x has to be equal to 0. Okay, and this is now a little tiny wee linear equation here. If I minus 2 off both sides, I end up with x equals negative 2. Okay, because minus 2 off both sides there. Now, this is a wee bit hard to solve, but I have to get rid of that positive 5, so I'm going to minus it away off both sides, and I end up with negative x equals negative 5, and therefore I can simply know that changing the sign on both sides will give me that, and so I actually end up with two possible answers for the value of x. Okay, and let's just try it and see what happens. If I put negative 2 into x, then I get negative 2 plus 2, that's 0, times 5 minus negative 2 is about negative 3. 0 times negative 3 is 0. Alternatively, if I put x equals 5 into the equation, I get 7 times 0, and that's also equal to 0. So you see there are two answers for that example. Here's another one before I go back up the top. In this case, we have two things multiplied together. I have an x and I have an x minus 3 multiplied together. That means that if either that equals 0 or this here equals 0, alright, and to find out what x has to be to make that 0, I'm just going to solve that tiny wee equation. X equals 3 will make that equation 0, or that part of it. There are my two possible answers for x that will make that equation equal to 0. So the steps for solving these types of equations, first of all, is to recognising that it's a quadratic equation. It has an x squared in it. And if I go down gently to these ones, you'll see this is quadratic because at some point I'm going to multiply x by x. That will give me an x squared. I go down to the second example here, I'm going to multiply an x by an x. So that would make it an x squared. Okay? But the rules are very, very different from linear equations. So the first rule is, step 1, the right-hand side, I shortened it to RHS, has to equal 0. And in each of the examples there so far, the right-hand side was 0. If it's not 0, you need to make it 0. And that would involve some expanding here, some removing of whatever's on the right-hand side until there's nothing left to make it equal to 0. Okay, once you've made the right-hand side equals 0, the other side, the left-hand side, has to be factorised. That means made into brackets so that you've got things multiplied together. Here's a bracket multiplied by a bracket. That means it's factorised. Here is a thing multiplied by a bracket. That means it's factorised. And finally, we do what's called the null factor law. We apply that, which is what we've been doing here. We've taken each of those factors separately and we've solved the resulting x value for those. Okay, so what I'm going to do now is go on to example 3 and we'll apply these rules. Okay, now this is a quadratic equation. This one's a lot more obvious because it has a square in it already. Alright, so the right hand side has to equal 0. Yes, it already equals 0. The left hand side needs to be factorised. Alright, that's step 2. So we factorise the left hand side. Now this one's going to end up with 2 brackets because we have a square and a number by itself, so that means 2 brackets. Okay, for this I'm looking for factors of 36, negative 36, which add together to make positive 9. Hope I've got that right. Okay, so I've got 136, that's not going to do. 218, 312, that's going to be it. 312. To make positive 9, I need to have a positive 12 and a negative 3. So that makes x minus 3 and x plus 12. So there's my factorised version of that equation. So that's step 2 done. Now we do the null factor law. So the null factor law takes these 2 factors separately, x take away 3, and makes it equal to 0. Or the other factor, x plus 12 equals 0. And we solve each one of those. So I'm going to add 3 to both sides here. X equals 3 is one of the answers. Alright, by the time I've gone plus 3, and this one here, I have to get rid of the positive 12, so I go minus 12, and I end up with the second answer of x equals negative 12. So there are my 2 answers for that equation. Just to prove it works, if x was 3, 3 squared is 9, plus 9 threes are 27, 9 plus 27 is 36, take away 36 equals 0. Okay, so it works. Alright, to example 4. Oh, here's an example. I have to first of all make the right hand side equal 0. Alright, remember that's always step 1. So I'm going to remove 9x's off that side, and therefore I have to minus 9x on that side as well. So x squared, take away 9x equals 0. Now I have to factorise the left hand side. Now this is interesting because I have an x squared but I don't have a number by itself. So this is going to be a single bracket factorisation. That's the one where you take the common things outside of one bracket. So what's common to both of these terms? Only the x. So outside the bracket goes the x. X times what gives me x squared? X times x gives me x squared. X times what gives me negative 9x? X times negative 9. And now my 2 factors are either x has to equal 0 or x minus 9 has to equal 0. And my 2 answers, well, there's one answer, I don't need to do any working there. This one here, I'd have to add 9, or x equals 9 is my other answer. So 2 answers there. Now here's an example. This is a very practical example. I have a cake, and I know that the cake tin is so many centimetres wide, but I know its length is 5 longer than its width. All right, now I don't know what x is, but I do know that the proportion of the sides, this is 5 centimetres longer, and I want my cake to have a base of 24 square centimetres. So this is an area problem. So the length times the width. Length multiplied by the width has to equal 24. Okay, so looking at my rules, the right-hand side has to be 0. Now, but to make it 0, all right, going back over here, to make it 0, first of all, I am going to need to expand this. So x times x is x squared. X times 5x, x times 5 is 5x equals 24. I have to make it 0, so I'm going to have to remove 24, minus 24, and I end up with x squared plus 5x minus 24 equals 0. So that's the right hand side equals 0. That's step 1. Now I need to factorise the left hand side. X squared, number by itself, that means 2 brackets, equals 0. Okay, I need factors of negative 24, which add together to make 5. So I'll just do that over here. We've got 1, 24, 2, 12, 3, 8, 4, 6. That's the one that's going to make 5. Now, one of them has to be negative because I've got negative 24 here. And one of them has to be positive. And one of them has to be positive. Now they need to add together to make positive 5. So the bigger number has to be positive and the smaller number has to be negative, and they add together to make positive 5. Now that means the two things here are x minus 3 has to equal 0, or x plus 8 has to equal 0. Alright, that means that either x is 3 centimetres or x equals negative 8 centimetres. Now, of course, that one doesn't make sense. It's a correct answer mathematically, but you cannot have a side which is negative 8 centimetres long. So what we would do there is say the cake tin has width of 3 centimetres and length of 3 plus 5, 8 centimetres. And then I would definitely have to say x equals negative 8 does not make sense in this instance. And I've run out of words space to put in this instance, but I would put that down there. And that's the basis of quadratic equations. A lot simpler, or a lot fewer rules than linear equations. These are the 3 rules to memorise if you have an x squared equation.